Data models are philosophically pretty interesting when you think about them. They're a way of connecting concepts that are going on in the real world to representations in bits on disks. And so it's a long way to go, and it's pretty interesting all the design decisions you can make along the way. There have been many data models proposed over the years, and I'm sure there will be more proposed in the future. We're going to ground ourselves in our lectures in the relational model because it's clean and simple, it's quite commonly used, and it's quite general. For example, it generalizes the notion of key-value pairs, which are used in key-value stores. Also generalizes graphs, and so the relational model is a nice kind of universal, simple model to work with. Another good model to know is the entity relationship model. It's actually nice for the design phase. It's good for when you're talking to people who are less technical, as well as when you're just whiteboarding out ideas. And the nice thing about the entity relationship model is also that it will translate down to the relational model. So we'll be looking both at the relational and the entity relationship models today. The entity relationship model is something we haven't seen before in this class. And it comes from the fact that the relational model, while it's a great formalism, is a bit too detailed for design time. It's kind of a fussy model. It asks you to kind of define these rigid rows and columns and pick types, and it can get in the way of brainstorming, particularly when you're talking to people who are less technical. It's very hard to communicate to customers in SQL DDL statements. It's much nicer if you can draw pictures, stand at a whiteboard, and kind of figure out how things connect up visually. And so the entity relationship model is that kind of a visual model. It allows you to draw graphs, so it's a graphical model, and it can be viewed either as the graph that you draw on the board, or in some sense, you could view it as a thin veneer, almost just code word representation over relations. So in fact, at some level, it is a relational model, and we'll talk about that later today. The thing is that the entity relationship model, it feels more flexible. It's a more sort of brainstorming, open design model. It's less structured than the rigid rows and columns of the relational model, in some, at least, psychological sense. It corresponds quite nicely to these object relational mappers that we've talked about, these ORM software packages like Ruby on Rails, Django, Hibernate, SQLize, and so on. And so the entity relationship model actually has had something of a renaissance in recent years in programming language packages. So to put this back in context with our database design steps, ER diagrams, entity relationship models, fit in here at the conceptual design level. Conceptual design itself boils down to asking questions like, what are the entities that you're trying to capture in the real world in your database? And what are the relationships between those entities that are important? And what info for each entity and each relationship should we be recording in our database? So that's sort of the most basic level of entities and relationships that help us describe what's going on in the world. We might ask somewhat deeper questions too, like what integrity constraints have to hold on these entities and relationships? What must be true of these entities, and what must be true of the way that they relate to each other? Sometimes, because databases are so often used in business contexts, people refer to these integrity constraints as business rules. But of course, even if you're not running a business, but you're building a database for some other reason, maybe it's a nonprofit, these kinds of integrity constraints can be important. An entity relationship diagram is a schema in the entity relationship model. This is actually a visual schema for this model, but we'll be able to map an ER diagram into a relational schema, as we'll see. So conceptual design, this level of the stack, is really where the data engineering begins. Up above in requirements analysis, you're really doing a lot of sort of understanding of the processes of the organization you're trying to capture. But in conceptual design, you're beginning to design data, and you're beginning to design the system that will hold your data and allow you to query it. If you're familiar with jargon from programming languages, conceptual design are essentially the M in the MVC pattern. The models, M of model version controller that's used in ORMs, are basically conceptual designs and actually often very similar to entity relationship models.